Welcome to Cosmic Compass, the channel where we explore the wonders of the universe, one story at a time. From the planets in our solar systems to the deepest mysteries of space, we journey together through science, history and discovery. In today's episode, we'll unravel the invisible shield that surrounds us, Earth's atmosphere. It's more than just the air we breathe. It is a layered, intricate system that protects us, shapes our climate, and even paints the colours of our sky. Let's dive in and uncover how each layer works and why without them, life as we know it could not exist. We live on a planet that in many ways is incredibly fortunate. Most of the time we barely notice it, but every breath we take is possible because Earth surrounds us with a life-giving atmosphere rich in oxygen. This invisible blanket does far more than sustain our lungs. It shields us from the hostile vacuum of space, protects us from dangerous radiation, and even gives us the blue sky and sunsets we cherish. Without it, Earth would be a barren rock unfit for life. Today, let's take a journey together through the different layers of Earth's atmosphere. We'll uncover how each layer works, why it matters to us, and what mysteries still linger above our heads. By the end, you'll see our atmosphere not just as air we breathe, but as a complex and elegant system that makes our world habitable. If we ask someone where Earth's atmosphere is, they might confidently gesture just above the clouds, maybe up to where planes fly, but the truth is far more surprising. From the International Space Station orbiting at around 340 kilometers above Earth, we still see the faint glow of atmospheric layers below. And yet, even here, we are not truly beyond the atmosphere. In fact, depending on how we define it, the atmosphere stretches far into space. The exosphere, its outermost layer, can extend tens of thousands of kilometers, up to halfway to the moon. What most of us recognize when looking up at the thin veil of air is just a fraction of the full picture. To really understand it, we must dive into its layers, starting with the one we all live in, the troposphere. The troposphere is the lowest and thinnest layer of the atmosphere, but it is also the most important for life. At the equator it reaches about 20 kilometers high, while at the poles in winter it shrinks to just 7 kilometers. Inside this thin slice of air, we find around 75% of the atmosphere's total mass. This is the layer of weather storms, rain, snow and wind. If you have ever climbed a mountain and noticed how much colder it felt at the summit than at the base, you've experienced one of its defining features. The temperature drops steadily as we rise by about 6.5 degrees Celsius per kilometre. But why does this happen? To answer, we need to understand how the sun heats Earth. Most of the sun's radiation passes right through the atmosphere. Instead, the ground absorbs this energy and then transfers heat to the air above it. Dark, matte surfaces like asphalt are especially good at absorbing sunlight, which is why cities often feel warmer than surrounding countryside. This heat then spreads through the air in two main ways: conduction and convection. Conduction is the transfer of heat from one particle to another, much like how a pot on a stove heats the water inside. Convection, on the other hand, creates great circulating currents. Warm air near the surface rises, expands as pressure drops, then eventually cools and sinks again. These circulating patterns, called Hadley cells, shape global weather. They are responsible for trade winds, rain belts near the equator, subtropical deserts, and even jet streams that circle the globe. There's another beautiful effect at work in the troposphere one that explains why our sky is blue. Sunlight consists of many wavelengths, and the tiny gas molecules in our air scatter shorter, higher energy blue light more than other colours. The result is the endless blue sky you see above your head every day. Without the troposphere, our world would have no clouds, no rain, no climate as we know it. It is the foundation of life's delicate balance. Above the troposphere lies the stratosphere, stretching from about 20 kilometers to 50 kilometers high. Unlike the troposphere here, the temperature actually rises with altitude. Why? Because of one extraordinary feature. The ozone layer, Ozone, a molecule made of 3 oxygen atoms, plays the role of guardian. It absorbs much of the sun's dangerous ultraviolet radiation, preventing it from reaching Earth's surface where it could damage our DNA. Interestingly, ozone itself is constantly created and destroyed. UV light splits oxygen molecules apart, then the atoms recombine to form ozone, only to be broken down again. This continuous cycle shields life below. You may recall how in the late 20th century scientists discovered a thinning of the ozone layer above Antarctica. This ozone hole became a global concern, reminding us how fragile and vital this protective shield truly is. The stratosphere is calm compared to the turbulent troposphere. Air moves mainly in horizontal streams, which is why commercial airplanes often cruise here, avoiding storms and turbulence. On rare occasions, spectacular nacreous or mother-of-pearl clouds shimmer at high latitudes, glowing with iridescent colours as the sun dips below the horizon. This is also the layer from which Felix Baumgartner, the record-breaking skydiver, leapt from 39 kilometres up. Even at that altitude, he was still well within the stratosphere. Climbing higher, we reach the mesosphere, extending from 50 to 100 kilometres above Earth. Here temperatures plunge to the coldest anywhere in the atmosphere, down to minus 143 degrees Celsius. Air pressure becomes vanishingly thin, just 1,000th of what it is at sea level. The mesosphere is also home to one of Earth's most beautiful and elusive sights, noctilucent clouds. These glowing silvery clouds form 76 to 85 kilometres up high, enough to still catch sunlight even when the ground below lies in darkness. They are made of tiny ice crystals, possibly seeded by dust from meteors or volcanic eruptions. Sometimes even the exhaust from rockets can contribute to their creation. Scientists sometimes call the mesosphere the ignorosphere. Why? Because it is one of the least explored regions of our atmosphere. Too high for planes to fly, too low for satellites to orbit safely, it remains largely out of reach. Only sounding rockets can briefly pass through, giving us fleeting glimpses of its secrets. Above the mesosphere lies the thermosphere, stretching from around 100 to 600 kilometres. Despite being incredibly thin, this layer can reach astonishingly high temperatures, up to 2,000 degrees Celsius during periods of strong solar activity. But here's the paradox: it would still feel freezing to you. The air is so sparse that there are too few particles to transfer much heat to your skin. Many satellites orbit within the thermosphere, including the International Space Station. But because the atmosphere is still present here, though faint, it gradually slows these satellites down. Over time, without occasional boosts, their orbits decay and they eventually fall back toward Earth. The thermosphere also gifts us one of nature's most spectacular displays, the auroras. High energy particles from the sun collide with atmospheric gases, causing them to glow in shimmering curtains of green, red and purple light. If you've ever seen the northern or southern lights, you've witnessed the thermosphere in action. Finally, we reach the exosphere, the outermost layer of Earth's atmosphere. It begins somewhere around 600 kilometres above Earth and stretches out to 10,000 kilometres or more. Here, the few particles that remain, mostly hydrogen and helium, are so far apart they rarely collide. They drift slowly, still bound by Earth's gravity, but at the very top of the exosphere, even gravity loses its grip. At this boundary, the radiation pressure of the sun pushes them away into true interplanetary space. From the surface, we may think of the atmosphere as something local, immediate and invisible. But here at the edge, we see its vast scale. The atmosphere is not just the air we breathe, it's a protective cocoon extending halfway to the moon, connecting our planet to the wider cosmos. And so we've journeyed through the layers of Earth's atmosphere, the troposphere where life and weather thrive, the stratosphere with its protective ozone, the mysterious mesosphere, the fiery thermosphere with its auroras, and finally the exosphere where Earth fades into space. Each layer plays a role together, forming a shield that allows life to exist. Without it, there would be no breath, no water cycle, no protection from the sun. Next time you look up at the sky, whether it's a bright blue afternoon or a starlit night, remember that you are gazing through this incredible layered structure that makes our planet unique. If you enjoyed this exploration, don't forget to like, share and subscribe to Cosmic Compass. Together, let's continue uncovering the wonders of the universe. Thank you for joining us on this journey through Earth's atmosphere. From the clouds above our heads to the very edge of space, we've seen how each layer plays its part in making our world alive and vibrant. If you enjoyed this exploration, don't forget to like this video, share it with fellow space enthusiasts, and subscribe to Cosmic Compass for more stories that take us beyond our world. Together, let's keep reaching for the stars and continue uncovering the secrets of the cosmos.